My name is Dong Choi, and this is Shinju Kim. So we are going to introduce a paper named DeepClair, utilizing market forecast for effective portfolio selection. So this is our research question and our dream to create a model. So can you imagine a machine that can automatically allocate your investment while predicting future prices? So I will explain the details of implementation on this research question. So before going forward, I will explain the task named portfolio selection. Portfolio selection is an investment strategy that takes a combination of assets best satisfying an investor's needs under uncertain market circumstances. So as you can see, if there, let's say, if there are two assets we are interested in, and then maybe if we can figure out the first asset is going, maybe it is going up in the future, then maybe it is better to put more asset on that, put more money on that asset. Maybe in the opposite way, it could be possible as well. So traditionally, investors assume that the current market trends will persist in the short term. But what if we could predict future trends more accurately? So this is another perspective of kind of technical perspective. So the evolution of time series forecasting models witnessed a significant transition from earlier approaches to the advent of transformers. So as you can see, there are a lot of transformer variants to solve the problem of time series forecasting. The task is so using the previous historical prices, predicting the future price would be the problem. So the following question would be, what if we can harness the clairvoyant power of forecasting transformers in portfolio selection? So we are going to introduce DeepClair, a deep clairvoyant portfolio selection model that leverages not only its current understanding of the market situation, but also its forecasting of future market states. So this is the overview of our DeepClair framework. As you can see, there are two main parts in the framework. The first part is market price forecasting model utilizing supervised learning technology. And then another part is about creating a portfolio. So by doing that, we are going to use a reinforcement learning technology. I will going to explain each part one by one. The first part is learning to forecast market. The objective of test 1 is training a market price forecasting model. So as you can see, this one with a supervised learning setting. So the training objective is minimizing the difference of predicted price. So as you can see in here, this part is from the market price forecasting model, and minimizing the difference from this part and the ground truth price. And then this is quite the realistic scenario that the task 2 is about learning optimal portfolio selection using the transferred market forecasting model. So as you can see, this model will be transferred to this model. So, and also in this part, there are two main components in this model. So first part is market scoring module. Is utilizing the transferred ability from the trained market price market price forecasting model to decide the proportion law. So as you can see that using the outcome of price forecasting model, the model decide the proportions of assets. And also we have another part named asset scoring module and portfolio selection module to decide the like long and short position of the agent. So by multiplying the two factors, we can decide the actual portfolio position. And note that the training is done with reinforcement learning criteria, so all the modules are trained with trial and error manners, so which is quite different from the test one. As I explained before, the test one objective is supervised learning, so the model is kind of following the like future trend or prices, but in this case, the training is done by the trial and error manners. And also, I want to emphasize that we freeze the transferred weights, which is here, in the market focusing model, and train it with a small additional weights with ROAT framework. So, which means we only train these kind of small weights inside the market price focusing model in this framework. So, yeah, this is the result one of our model. So the result one is for demonstrate our model selection of forecasting module. So as I said before, there are multiple choices of time series for transformer-based forecasting models. So like we compare the models with the normal experiment domains, ETTH or electricity, and also this is quite relevant to our domain, which is stock price predictions, Nasdaq and Dow Jones. And as you can see, all the metrics in all the metrics, Betformer shows the best result. So we decided to select this one as our backbone model for forecasting module. And this is our main result for portfolio selection tasks. As you can see here, so AIR and ASR and CR and Sortino is quite related to return. So our DeepClair shows the best investment performance in terms of return and risk-adjusted return metrics in two domains, including Nasdaq and Dow Jones. And we try to compare our results with the previous frameworks, including benchmark index and traditional investment strategy, CSM and BLSW, and also the other recent work, including EIIE and HADOX and Deep Traders. For ourselves, it is quite interested in that our results could beat the benchmark index, which is quite quite good when it comes to return, around 6% or 9% per year. And also, we did some ovulation experiments to demonstrate our design choices make sense. First of all, in here, our choice of Betformer shows the best results compared with the other forecast transformer variants, including transformer, informer, and autoformer. So as you can see here, like all the result is like 5, 3, 5, 8, 6, 5, 8, but our result is much better than these kind of transformer variants. And also, our LoRa training strategy outperforms other optimization options. The first one is like not transferring the pre-trained weights, which is annotated as removed, and also freezing the transferred weights frozen. So, which means this case doesn't train in with the task 2. And also another case is fine-tuning all transferred weights, annotate with fine-tuning. So I think this is quite interesting for us as well, because the LoRa framework utilizes smaller weights compared to fine-tuning, but our results shows better results compared to the fine-tuning strategy. The last one is that applying LoRa, our choice of designing the encoded parts in the fat former outperforms other cases of applying to other components, including decoder, FEA, or all components. And this is kind of our investigation on DeepClair's investment. As you can see, without training on the task 2, which is quite realistic scenario, the frozen case shows kind of like not adaptive way to like when it comes to the changes of prices. But our cases shows better results compared to the frozen case, and also this is another interesting case that fine-tuning case doesn't change their position when the price going up in P3, but our case shows adaptive choices in this case. So in conclusion, the contribution is like, first of all, this is the first attempt to incorporate the current transformer-based market forecasting methodology into an automated portfolio solution framework, and also we trained recent proposed transformer-based models on various time series data set, and empirically chose this kind of design choices. And experiment, we show that our DeepClair shows the best among the scenarios. Thank you, and we have
thank you for the presentation. Have you observed any stability problems during the training of the reinforcement learning part?
Sorry, but pardon?
Have you observed stability problems?
Stability. So this is a very important problem, and we also had a lot of problems with that. There's another reason we use the LoRa and those kind of things. So first of all, without using the actual market forecasting model, always we had a lot of problem with the stabilize all the process for the reinforcement learning. But as you can see that the market it is known that supervised learning is quite easier relevant to the reinforcement learning. So as you can see in here, even with the LoRa, the market focusing model the output of the predicted price is quite stabilized compared to just randomly choose the other framework. So what I want to say is that utilizing this kind of market schooling module, we can stabilize all the reinforcement learning procedures. That was quite our #1 investigation. We are proud of.
I'm curious about that. How many kinds of data you used to train your model?
How many? Sorry.
How many kinds of data?
Dates.
First.
Dates.
The
period.
Period. How big the data size of?
Here. So we use this kind of data sets.
So task 1, we use about like 12 years for the training.
Also,
Yeah.
you use long time series, but not many kinds of time series, such as stock time series or many kinds of prices time series or weather time series.
So for this portfolio selection task, we only use the stock price time series data to first
Okay.
pre-train the Fed former, and then we transfer the weights of the Fed former to our reinforcement learning framework.
And
And
I also want to know if the date is much bigger and the effect will get better.
you mean, so if the duration, the time period of the training partition, if it's longer, then it will be more beneficial. Yeah, basically yes, but we wanted to make it more of a very difficult, stricter evaluation setting. So for the time forecast, we only use 3 years worth for the test. But for the portfolio selection, we extend it to like 16 years for the portfolio selection scenario, which is more challenging.
Thank you.
Yes.
Due to time constraint, yeah, we need to move the next speaker. Please feel free to approach during the break.